Welcome to the pre-calculus video for skill number 23. I can evaluate and write composite functions from tables, graphs, and equations. And since we're in the compass unit, I wanted to talk about these two images here. A compass is used on Earth to point us towards the North Pole, or sometimes we even have south-pointing compasses. And featured below are two objects. Same object, different eras in time. And the trivia question is, what is the name of the object used to discover the strength and direction of the magnetic field on Earth? Alright, we'll start our notes on page 23A. A composite function is when the output of one function is used as the input of another. We call this entire operation a composition of functions, and we can write f parenthesis g parenthesis x close parenthesis, or f, and then we have this small circle right here, g parenthesis x close parenthesis, and we read both of these the same way, f of g of x, f of g of x. So this little circle here kind of stands for of. So we say f of g of x. And in example 1, I'm going to walk us through a couple composition of functions. So we are given that f of x is 2x plus 1 and g of x equals 3x minus 7. And the first question is to find f of g of 3, which means we're going to first evaluate g of 3, which is what we've done here. We plug 3 into our g function, and we get an answer of 2. And that's the number we're going to plug into our f function. So then we take our number 2 and we plug it into our f function, and it gives us the value of 5. So f of g of 3 is equal to 5. Then we go in the opposite direction and we say g of f of 3. And the same process applies. First we're going to find out what is f of 3. So we plug 3 into our f rule, and we wind up getting an answer of 7. And so now we want to evaluate what is g of 7. So we stick 7 into our g rule, and we get 21 minus 7 is 14. So g of f of 3 is 14. And you should notice that those values are not the same. And they are not necessarily ever going to be the same. Sometimes they are, but you cannot make that assumption. So I stated that at the top of the next page of our notes. It's important to notice that f of g of x is not necessarily equal to g of f of x. Another way we might be asked this question is through the use of tables. So what we have here is a table with x values 1, 2, 3, and 4, and then we have f of 1 is 6, g of 1 is 3, f of 2 is 8, g of 2 is 5, etc. And we're asked to find f of g of 3. What that means is we're going to find g of 3, and if we look at our table, g of 3 is 2, so we're asked to find f of 2. And so we look at our table and find that f of 2 is 8. Looking at the further examples below, what we've got is g of f of 3. So first we have to find f of 3. So f of 3 is 3, and g of 3 is 2. In the third example, we're doing f of g of 4. So g of 4 is 7, and f of 7 is not on the table. So I just wrote not included in the table. I'll let you look at the last two examples using the table. Sorry, last three examples. So in the final example, notice I composed it even further. Rather than just two functions, I went to three functions. So first I need to find f of 3, which is 3. and then I want to find g of 3, which is 2, and then I want to find f of 2, which is 8. So we can go as deep as we want. We can have multiple functions, f of g of h of f of x. If we wanted to compose 4 functions together, 1, 2, 3, 4 functions. Generally, we'll be asking only 2 functions, maybe 3. But in truth, we can go as deep as we want. Alright, in example 3 I'm showing how to do this from a table. Sorry, not a table, but from a graph. So first we're asked to find f of g of 3. So what that means is we're going to go over to 3 on our graph. 1, 2, 3. And g of 3 is a value of 1. So I can replace g of 3 with 1. And now I want to evaluate f at the function at 1, so I go over to 1, and the value of f is 6. And I did the same thing for g of f of 3, and then I did another 3-piece composition, so f of g of f of 8. So for f of 8, I went all the way over to 8, the function value is 1 there, so now I need to find g of 1, which is 1, and now I need to find f of 1, which is 6. The final piece is example 4, and now instead of plugging in numbers, we're actually plugging in equations. So here I'm given the function f, and I'm given the function g, and I'm asked to find f of g of x, which means I'm going to plug g of x, just as is, into the spot, g of x, and then this will then go into, since I'm evaluating the function f, this will go into the variable of the function f. So what we wind up having is x squared becomes 2x minus 3 squared plus 5. I can pose the functions in the other direction, g of f of x, which means I'm going to take my f equation, my f rule, and I'm going to plug that f rule into the variable for g. So we're going to plug it into that x, and we get 2 times x squared plus 5 minus 3. If we wanted to, we could take these functions further and simplify them, but I would encourage you to not do that because oftentimes we make mistakes in the simplifying process. So a straight up substitution is good enough for me. Just know that when you're taking like a multiple choice test or something, they may have simplified this. Like the bottom one simplifies to 2x squared plus 10 minus 3 is plus 7. So the bottom one simplifies to that. The top one is a little bit harder to simplify. It's 4x squared minus 12x plus 9 plus 5 is plus 14. I'm pretty sure the top one simplifies to that. But feel free to check my work. Get extra credit if I made a mistake. Alright. Alright, thanks for watching the video, and the answer to the trivia question is the two images below are of objects called magnetometers, and they're used to measure the strength and direction of the vectors of a magnetic field on Earth or in space.